start. Okay, this is the answer I expect to get also. Let's just start. Okay, anyway, just to remind you, okay, this is week number 10 already. You still have 2 more weeks to go. Okay, now last week we finished until chapter number 6, polymorphism and inheritance. So today we go through one more new topic here. We call it as a abstract class and also the interface. Abstract class interface. Now before I start the lecture here, try to look at this example. Okay, I always like to show the example before start. Okay, imagine let's say now in my code, I have a student called local student and international student. Okay. Let's see. Okay, local student. This one is a calculation for the local student bill. Okay, local student bill. You know how to calculate the bill for the student bill? Depend on the number of credit per semester, right? Yeah. So let's say this semester you have a 10 credit, then 1 credit times how many you have. So assume now, let's say for local student, amount of credit is 290. Okay, then depend on number of credit you have. Then to calculate the fees is number of credit times the number of credit times this amount of credits. Okay, so you get the fees for a local student. So same thing happened to here. I have another class for international student. Okay, international student maybe the fees is higher. Okay, compared to local student, now we have 290 per credit. This one is just example only. Okay, for international student, maybe you have a higher charge for them. Okay, 450. Alright. So again, here we apply the same formula here. Number of credit times amount of credit per hour. Okay, this one the amount of hour times this. So this one we call it as a calculate fees. This one we also call it as a calculate fees. Alright. Okay. So from here, first of all, last past chapter you learned the generalization, right? In the generalization, what you should do? Assume now, let's say these two classes are international student and the local student here. We have a same common attribute called number of credits. Same thing happened here. We have number of credits. Then again, we have this one called calculate fees. Then here also call it as a calculate fees. So generalization, what you should do? Okay, in the generalization process, we take out the common attribute first. Which one is a common attribute? This one, right? The fees is different. Now this one and this one, the fees is different. So we're not going to take out. Of course, if you want to put it under the general class called student bill here, you can do so. Okay, meaning to say you need to have a two constant value. Okay, two different constant value. So imagine, let's say now I'm going to take this one out. Okay, number of credit and move it to cut this one. I cut this one and move it into my parent class over here. Okay, this parent class basic. Okay, number of credit. It apply to both type of student, international and local student. Then again, the method is the same thing. We try to do the generalization also. Since both classes having the same method called calculate fees. So I should move this one to the parent class also, right? Okay, in the generalization. So we try to move this one. Okay, so now you try to see, if I try to move it to the parent class here, then you encounter another one issue. How to calculate the fees. If you try to move it here, calculate fees. In the international student, we have this formula. In local student, we have another types of formula to calculate. So once you move it into the parent class, do you know how to do the calculation over here? Anything that you can do? No, you can't calculate. There is no way for you to calculate unless you know the person is coming from international student or from the local student. Then only you manage to calculate, right? But in the general class here, the student, when we do the generalization, we just need to we just know that we have one function called calculate fees. But the formula, the details, we did not know. So this method, it become abstract. That means that the method is no way for you to do calculation. See that? It's too general. Okay, it's too general until you did not know what to do. Okay, so in here, this method we need to add in the keyword called abstract this time. Okay, these keywords. Abstract means that the function is yet to complete. Okay, this function is yet to complete. So when you need to complete it, you need to complete it under the subclass. Okay, right? Okay, so what I need to do here, I move it here. This method calculate fees and make it as an abstract. Then after you make it as an abstract, you take notes in here. The student view class, the compiler start to complete. Okay, what compiler trying to say? Non-abstract. Okay, student view is non-abstract, and you need to override. Okay, you need to override over here. Override means that you need to come out the function body, but there's no way for us to calculate. So what happened here, when you have an abstract class, means that this method is yet to complete. Can I consider the class completed also? This method is yet to complete. Can I say the class is completed? No, right? You build a car without a tire, or without a door, or without an engine. Okay, engine yet to put in. Then we say that the whole car is yet to complete also. So same thing happened here. Calculate method is yet to complete. I need to put this one abstract also. Okay, so I tell the compiler this class is yet to complete. Follow that? Okay, so we come to your subclass. Okay, this subclass we need to do the extend. Okay, extend from this one is a student view. Okay, we try to extend. So when local student extend from the student view, inside the student view, we have a class method calculate fee is yet to complete. So you need to finish it within the method subclass over here. Okay, you do the extend, that means that the incomplete method will be inherited to the subclass. So what to do? The subclass need to implement this method here. Okay, so override the parent class. Got it? Okay, okay, so we do the same thing for international student here. We try to do the extends. This number of credit will already move to the parent class, so we do not need to repeat the attribute again. Okay, this one extends student view. Alright, this part. Okay, and last week we also learn. Okay, if I would like to make my attribute to be direct used in my subclass, what should I do? If I put private here, means that subclass cannot direct access, right? You can see that this top number credit having the issue. Okay, this top number credit having an issue. So how to make this attribute can be direct access from the subclass? What should I change from private to? Yeah, change it to the protected sub. Okay, protected. Got it, huh? So when you change to the protected, then everything is solved. So in here you can direct access to your number credit. Okay, then by this number over here. Clear this part? Okay, so inside the notes you can try to see in here they're telling you, okay, subclass actually we call it as a specific class. That means that more level you go down, you have more and more attribute added in. Okay, right? Example geometry object circle. Circle maybe you just have a radius. Under the circle maybe you have the cylinder. Cylinder have more attribute comparing to the circle. Okay, right? It's the same opposite. When you go more and more upper level, then the class become more and more general. See this? Specific when you go down, then general when you go up here. So until certain point when you go up, there is no way for you to implement. Then only we say this class is an abstract class. Okay, got this part? Clear? So example given in here, calculate area, get parameter. These two methods is the same. So when we do the generalization, of course we need to put this method on the parent class. Okay, put this one, get area, get parameter, move it into the parent class. But the issue is when you move it into the parent class, there is no way for you to calculate parameter. There is no way for you to calculate the area. It's too general. You cannot apply formula in a geometric object class over here. Okay, so this class you need to make it as an abstract. Got this? So in here we say get area, get parameter. There is no way for you to calculate. So make the class itself as an abstract. So in the UML notation, when this method is an abstract, usually you're going to see the italic. Okay, the form style, it becomes italic. And the class itself also an abstract. Then the class, you can see the name is italic. See this one? Okay, you need to know the difference. In the UML notation, regular form style is stand for a regular methods. Okay, it can be a concrete methods. Concrete method is opposite for abstract. Concrete method means that everything is fully implemented. Okay, abstract method is something is missing. Okay, the body is missing. Okay, otherwise, italic lines. Okay, for this one, it cannot be implemented. Okay, this one. So in here we need to know that we need to add these keywords, right? Abstract keywords in here. Then in another one over here, if I make my class is abstract class, okay, this student view, I make my class as an abstract class over here. You need to remember abstract class is not complete. Can you create the object? If something is not complete, can you try to create the object? No, there's no way for you to create an object. So what happened in here, if I try to come out a test program, okay, maybe I call it as a test, this class. Okay, last time, if this is without the abstract keyword, you can free to create this object. Let's say student view as, or maybe view equal to new student view, right? New student view, this case. But due to this time, okay, due to this time, the student view you declare as an abstract, this one, the keyword abstract, that this class is not yet complete. So you cannot create an instance. See from here. Okay, you cannot create a new student. This is wrong. The compiler do not allow you to do so. See that? Okay, this one you cannot create that. So you can see from here, new keyword, it will involve which method. If every time we have a keyword new, which method will be involved? Constructors, right? Constructors. So meaning to say in here, I have a constructor. Usually you define the constructor as a public keyword. Public. Maybe I just add in here constructor. It's a code for constructor. Okay, this is a constructor. Normally you see the constructor is a public. Okay, public means that you can access outside the class. But now, since this class, you make it as an abstract, there is no way for you to create outside the class here. See that? You cannot call this constructor anymore. So for abstract class, usually this constructor, we're going to change it to protected. It means that this constructor is only applicable for the children class. You are not allowed to access outside, but you're allowed to access it during your subclass. See that? Okay, right? In a subclass, which method is calling? Let's say this is a constructor. I need to pass in this credit hour. Okay, this is an integer, credit hours, credit hour, I put this way here. Okay, CH, credit hour, number of credit. Okay, maybe just put credit. Okay, this credit equivalent to credit. Okay, this way, this dot credit, number of credit equal to this credit. Right? So now, when is the subclass calling this superclass constructed? Inside the student view. This is direct access, right? Get direct access. Or sometimes, let's say you do not want to make it as a, just in case, sometimes you do not want to make this as a protected. So you can try to make it as a private also. Depend on the need. If you want to direct access, you turn it to the private, turn it to the protected. If you do not want to direct access, you still can make it as a private. So in here, when you make the protected constructor, it means that you still allowed to call it, even though you are not allowed to direct access. But there is another alternative way using super. Then pass in the data. Okay, pass in this data is the same thing. You assign the value to the credit hours. See this one? You get it? Okay, so of course in here you can have a setter and getter to get the numbers. So for easier to access, I will going to make this one to protected. Okay, just to let you know, constructor in the abstract class, usually we try to put the access modifier called protected over here. Okay, abstract class protected. See this one? Okay, so that's why in your notes also in here, geometry object is a constructor. Okay, geometry object is a constructor, and this class is already defined as an abstract. That means that no way for you to create instance anymore, no way for you to create objects anymore. So this constructor is only used in the subclass. We put it as protected here. Clear this part? So there's a reason why we need to put this protected instead of public. In case you put the public, anything wrong? Just in case I put public over here, do you think anything wrong here? Nothing, it's still okay. It's still working, it's still acceptable. Okay, just in case you want to put private, just in case you want to put protected, it's okay. Alright? Okay, so example in the notes here, so these two methods as an abstract method always end with a semicolon. Okay, even though there is no body, you cannot just put the opening parenthesis and closing parenthesis. Here, open and closing bracket. This is not allowed. Open and closing bracket in the compiler will assume that you already make the implementation. Okay, get this one. So this method should end with semicolon at the end. Clear? Alright, this part. Okay, abstract method cannot be instantiated. What is meant by instantiated? This is a one. You cannot create an object for abstract class, but you still can use the method student view as a reference data types. That means that now I want to create a student for local student. Can I do that? Local student view. Okay, passing maybe 120 credits. You still can do so. You can make it as a reference data type, but you cannot create an object direct from the student view. See that? Okay, because local student is a student. Okay, local student is a student, so it's a view. This one is a view also. Okay. Okay, so extend the implement in the subclass. If you did not implement in the subclass, what will happen? Okay, let's say I come back to here. I try to extend my local student view. Extending student view, but if I do not do an implementation here, okay, if I did not do the implementation, you're going to see the compiler start to complain, say that this method is yet to implement. See that? Okay, there's a two solution. First of all, you can try to implement. Second solution, you make this class become abstract also. That means that maybe under the local student you have another subclass. Okay, it can be another subclass, so you want to implement the method in the another subclass, so you can try to make it as an abstract. Okay, abstract this case. When you make it as an abstract, then the compiler is happy, no error. Follow? Get this? So this part, of course, until local student view, we already know how to do the calculation for the fees, so it's better for you to implement. So shortcut in here, you can just click from here. You say implement all method, it will come up this method for you. Which method is yet to implement, it will come up. Okay, or else you can come manually checking from here, go to the parent class and check which method is abstract, then implement it in the subclass. See this? Okay, this part. This pro. International student. This one should be this one. This one I change it back to the original protected. Any question so far? This one, abstract method. Abstract what? Abstract attributes are the means. This one. attributes. There's nothing called abstract attribute over here. The big attribute you can, if you did not assign the value, means that you can just put an integer, something like this, like integer a, then semicolon. Not assign data. If you have data directly assign A, only you assign this field. There's no abstract attributes. Only for the methods. Okay, only for the methods in this case. Okay, so here say that it should be extend and implement in the subclass for all the abstract classes. Okay, method signature without the implementation. How to write the abstract method here? We need to have a method signature. Method signature means that the function header. So you can see from here, this is a method signature. Okay, starting from here until the closing bracket, this is a method signature. Then ending with the semicolon at the end. Okay, do not put a bracket, do not put a closing bracket, opening bracket in here. Okay, so method signature without implementation. All the details will need to implement by the subclass. That means that in your subclass need to write the formula. Okay, this is a one.
So, we have a question.
Yep.
Actually, what is abstract? Where is it for?
Okay, what is abstract for? Alright. Now, come back to here the reason for using abstract. Now, if I do not put this abstract, the keywords, do you think the code is working? Okay, if I do not put the abstract, this one is working up. Hold on, I change back to original. International student will assign this way. Okay. Assign this way. Okay. Got this, huh? Now I do not put abstract, that means that it's not override. This one, you can see there is no method abstract over here, right? Okay, right? In here, I have a function calculate fees. In here, I also have a calculate fees. The program still working, right? Even though I did not put the abstract method. Can get what I mean? But now what is the issue? Sometimes let's say you try to implement the local student view, but you forgot to implement this one. Okay, you may forgot to implement this method, or this method you give a different name. You call it as a calculate fees. This one you call it as a calculate fees. See the difference? Method name is different. Got it? So means that in here, when you want to call the function, okay, let's say now I come back. Okay, just test on this. Okay, just test on the test program here. Okay, now, without abstract method in the parent class, okay, once again, now you try to see, I did not put the abstract methods over here, okay, but in the subclass, I do implement calculate fees, okay, another method are using calculate fees, the spelling is different, right? So go to your main program, if I want to call this function, I call by using the different name, right? This is a logic, right? Okay, Now how about let's say I want to create one array to store all the student view. So this one come to student view array, right? I change it to the student view, and this time this is an array. Then now I'm going to store it, the first object for the array, the second for the array. Okay, second for this array. Then how you're going to write the code? Can I say that this B is 0, okay, B0, calculate fees, B1, calculate fees. Can you do so? Not allowed, right? So why it's not allowed? Because student view, you try to look at the student view. Student view is here. Do you have a method calculate fees? No. So you cannot print by using this way. Okay, you cannot print by using this way. That means that you have to do the casting from here. Is my bracket correct? This bracket operating this bracket here. Okay, you cannot call by using this one and this one, right? This one should be one. Okay, you cannot call by using calculate fees in this count fees and calculate fees. That means that this is because here do not have it. But now if you insist want to print, then you have to do the casting, right? Cast to the object called, okay, this is a local student, so we cast to the local student. Okay, cast to the local student. Then we try to, okay, local student I put count fees, correct? Count fees. Okay, so we do the casting this way. Then only I get this method. See that? Now imagine you have one array got 100 students. Do you manage to do this way? Not possible, right? Not possible. You do one by one checking and no. You need to write the for loop. Normally we write the for loop to do the printing. So now with this abstract, I'm going to modify this way. I'm adding in this method local student calculate fees. This one, right? I put it into here. Calculate fees. Now I make it to the abstract. Right? This is a double return and call it as an abstract. Okay, the class itself will be the abstract also. Okay, the count methods are now I make it to abstract method here. Then I come back to here, you can see there's no error in here. See that? You no need to do the casting. Now I do not want to do casting. This one I can just ignore. I still manage to get this function calculate. See that? Okay, right? Without this one, you come back to here, you get there is an error in here. Okay, with this abstract method, then you get this is correct. No issue. This is a dynamic binding. Okay, dynamic binding. You try to look for the paragraph. If this method this method is already implemented, yes, then you try to perform. Okay, right? Then now you may say another issue. This is using for the easier for you to write the coding by using this abstract. You can try to do the looping, then change this one to I, then you print out the data. Then the second reason we want to do the standardizing for the method name. Okay. Imagine, let's say in the class here, I put this one called calculate fees. Another one, I call it as a cal fees. So method name is not the same. Okay, if method name is not the same, then you need to do the instance of part-time student, you call this one. Instance of the local student, you call this one. Instance of international student, you call this method, right? Okay, so you need to do the switching always from one to another. But using this abstract, by using this abstract, you force all the subclass to have the same name. Okay, to have the same name. So in the parent class, I call it as a cal fees. In the subclass, I should name it as a cal fees. Then if I try to name it as a differently, then the compiler say that you haven't implemented method. Okay, standardization. The method name should be standardized all the while. Okay, right? Now this is very useful in case you would like to write something called a driver. Okay, your computer driver assume up, let's say you want to download a printer. Okay, a printer, very common thing, right? Okay, there is a printer. How many types of printer in the market? Let's say we have one called Canon printer, Brother printer, whatever, ABC lah. Okay, the manufacturer XYZ, whatever lah, XYZ. Okay, if you do not have a standardization here, this method can say that I want to print, I using this free, uppercase print. Another one I use a lowercase name called free. Okay, another one I using start free. Then now you want to install this printer to your computer. Okay, computer want to issue the command. What command I need to issue? Do I need to issue this command, or this command? If you install this driver into this PC, then you issue this command, right? Okay, right? But what happened here, if you install another type of, let's say now I issue the command uppercase print, it should be applied to this kind of printer. Now you try to install another type of printer, but issue this command, is it work? This is a lowercase p, right? This is a, one is uppercase p, one is lowercase p. This method and this method match or not? Not match, right? Then at the end, your computer say that this device is not compatible. See that? Because the name is not the same, I cannot issue the command. So what you need to do now, I need to make my all method inside using the same name in all the subclass. So I have one called printer. Okay, this one is called printer. Then I have another called printer inside. So if you want to extend from this printer, so you make sure all the name is the same. Alright? Okay, we do the standardization in all the subclass. So this is one of the reasons we're using this one called abstract method. Yeah, change back to just now. Okay, change it. Can follow on this part? Okay. Calculate. Okay, calculate fees. So here you have this name called calculate fees. In the local student view, you also name it as a calculate fee. So come back to here, you just need to issue one command. This command calculate fees will do. So using the for loop, no matter it's a local student or international student, I don't care. So you can just issue the same command calculate fees here. Okay, right? And it will be more easier to manipulate your code. Okay, right? Of course, in your assignment, if you did not put this abstract keyword, the program is still okay. Okay, it's nothing wrong. It's still okay. It's just to make the standardized for the method name. Okay, so from here you can see in your notes we have get area and get parameter. These two is an abstract, so we know that it's ending with a semicolon. And the class itself we need to define as an abstract. Okay, right? No question like this part? Almost the same example I mentioned just now. When you extend from the something is abstract, then you have to implement it. So you can see from here the method name is the same. Right? Get area, get parameter, and also get parameters here. Okay, and here I just show you, you cannot instantiate. Just now, you cannot say that student view equal to new student view. You cannot instantiate that. New operator cannot be used. Okay, you cannot say that geometric object equal to new geometric object, cannot. But you can try to create a subclass. Okay, you can use it as a reference data types. Okay, for all the subclasses. Okay, abstract method cannot be contained in the non. Okay, now another rules you need to remember when you have an abstract class. Okay, this abstract class not necessary to have this abstract method. Okay, I can say that I do not have an abstract method. Okay, the compiler did not complain. Okay, this abstract class, maybe I do not want to create an instance for this object, so I make it as an abstract. Okay, I do not want to create an instance, I make it as an abstract. It's work. Okay, but in a different way, you cannot say that you have an abstract method, but the class itself, you didn't make it as an abstract. This is wrong. You get it? So the rules in here, you can have one abstract method. You can have one abstract class, but without abstract method. But you have abstract method, you need to have abstract class. Get it? Opposite in here. Okay, abstract class may or may not. It may or may not contain any abstract class. Alright? A superclass for the abstract. Superclass may either be implemented. Okay, this one I mentioned in here. If your superclass is an abstract, okay, if the superclass is abstract, you need to implement the method. If you do not want to implement the method, then make sure the class itself in here should make it as an abstract. Get that? This one. The class itself declared abstract, or you need to implement. Okay, these two. Important point. Abstract method cannot be instant. Okay, again, this one is just repeat just now. You cannot create the instant. Constructor still needed. Okay, even though we cannot create a constant, the constructor is still needed. Remember why we still need the constructor? It may be used in a subclass. Okay, you may need the constructor in a subclass, even though you are not allowed to create a new instance. Okay, any issue in here? Yeah, any question this part? You refer to the example, you can follow, right? This one? Okay, this one is just repeat. You need, after you do the abstract, you need to make sure all the abstract class in the parent already implemented in the sub. Okay, right? Okay, nothing special in here. Okay. Another one example, just now I give you this example for local student and international student. So in the notes also mentioned that we give you another one more example. Optional means that it's not covered in the exam. Take notes. That means that in exam we won't ask you for the Gregorian calendar. Okay, Gregorian calendar, whatever related to the calendar will not cover. Okay. Just for your information, maybe you would like to use it in your assignment. You want to get the date, you want to get the year. Okay, you may use this Gregorian calendar. Okay, now in here when you say that Java util calendar, calendar can be many types of calendar, right? Okay, example, what kind of calendar? We have Gregorian calendar, we have the lunar calendar, we have the Jewish calendar. Okay, different kinds of calendar. So if let's say I would like to make an abstract class, which one should be the abstract? Gregorian calendar, lunar, Jewish, or calendar itself? The superclass calendar itself, right? And get it? So what method inside the calendar? Maybe you want to get months. Okay, get months, I want to be standardized all the different types of calendar. You need to have a method called get months, get year, get day inside that. Or maybe you need to have a method to set the month, set the year, get the different year, and so on. So all the method you can define as a abstract in the parent class in here. Okay, so anyway, this one is just an example. Okay, we have a lot of method inside there. Get time, okay, get date. So this Gregorian calendar is actually a stand for the general types of calendar. Okay, calendar here is a general. So to be more specific, you have a lunar calendar, Gregorian, and Jewish, right? Okay, try to look at this code. Maybe it's helpful for your assignment. You would like to get a year, get a month. Okay, you can see we can try to use calendar. Since a calendar itself is abstract, so we can use it for data types. Okay, in here we use it for data type. So calendar equal to new Gregorian calendar. We are creating the Gregorian calendar as an instant. Okay, you cannot say that in calendar, alright? So you can say calendar, not year, not month, not day, whatever. Number of week. Maybe you want to know the month. How many days in the month? Okay, how many days in the month? So you can say day of the month. Alright? You set the February, a certain year. Let's say this year, February. Then you want to know how many months in the February, it may be 28, 29 days. Okay, leap year 29 days. So you can try to get by using this one day of the month. Okay, right? You don't need to define everything, you don't need to calculate if else statement divided by 4 is a leap year or not. Okay, you can get help of this calendar object. Okay, right? So anyway, this is for your assignment purpose. Okay, next one is an interface. Now, interface in your assignment is up to you to implement. If you know how to implement the interface, yes, you're free to do. Marking rubric for assignment do not include this one. Okay, right? You need to know how to add in the polymorphism, inheritance, perhaps abstract class, but not this one. Okay, this interface. So what is an interface? So again now, okay, now come back to here. Just now we do something called generalization, right? Local student and this one international student. So more level you go out, then the data become more and more general. Okay, until certain point, if you let's say you continue to go out, until certain point they may not have any attribute inside. Okay, right? There's no extra thing, we call it as a common data. Okay, so no extra thing, but there is a common method, but we do not know how to implement. Okay, let's say I'm going to mention is a vehicle. Okay, vehicle is very general, right? So what are the methods is commonly applied to all kind of vehicle? Vehicle not only for car and lorry or tractor, so it can be applied to aircraft and so on. It's a kind of vehicle. Okay, so it's a kind of vehicle. What method you can see? What method you can say is an abstract method for the vehicle? Yeah. Methods. We are going to say method. Which method is considered abstract in vehicle class? Okay, maybe you calculate the vehicle, the age. Okay, maybe I can say that start engine, right? All kind of vehicle, different way to start engine. Okay, maybe the car, traditionally you're using the key return. Okay, maybe in the aircraft they're using the button to push. Okay, different vehicle there is a different way to start. Okay, but how we're going to implement the start engine in the parent class, there's no way. So the class method itself, start engine, I can create it as an abstract class. Can get that? Alright, so this part. Okay, then how about you say is plate number? Is all the vehicle having the plate number? When you try to move up to the top level, we try to find the common attribute, right? So is a vehicle plate number considered as a common attribute? Plate number. You remember the day Agun come to the how you see Agun open ceremony? Yeah. Do you notice that the car without a number? There's no number for the this lawyer car. Okay, right? So plate number is not a common attribute. So when you move out to the top level, it can be just a vehicle, including the methods only, without any attribute inside. You get that? So at this level, we call it as an interface. Okay, right? This interface means that inside the class there is no more common attribute. Sometimes we have a method, but we do not know how to implement it. Got this one? Okay, right? This one, right? So example in here we say interface interpol. Interpol means anything that you can eat. Okay, how to eat? Okay, how you eat durian? Open your mouth.
Open mouth.
Okay, how you eat KFC? Open your mouth also. Okay, baby. Okay, how to cook certain thing and how to eat. This one is just an example, okay? So we say that anything that you can eat, you need to implement this one how to eat. Fruit, you can eat the fruit. So how you eat the fruit, there's a different way to eat. Okay, then maybe food also, okay, different way to cook the food and you may try to eat differently. So this class is no more common attribute in here. Okay, so you say that it's an interpol. So in that case, you may name it as an interface. This is an interface file. So when we come to the interface file, we normally store only the constant. Remember, the interface file only constant and abstract class. Okay, this is a rules, constant and abstract class. So how to create the interface file? Okay, right click, go to the new, and you should see there is one called interface. No longer use a Java class. Okay, don't use a Java class. We using this interface. Okay, interface. Maybe I'm going to create one interface class called A. Just example. Okay, this class called A. Okay, this class called A. Then if you try to put in a method, usually you put a public. Let's say this method do not return anything. Okay, then maybe this method is called do something, I don't know. Okay, do something. Okay, abstract method always ending with a semicolon. Abstract. In here, remember this is an interface. No longer a class anymore. Usually we have this class. Okay, so when this is an interface, it will be public interface. Okay, public interface. So in this public interface here, we have one abstract method. Okay, this abstract method in the rules say that under the rules, this rule say that inside the interface it can only contain a constant and abstract method. So meaning to say, if I did not put this abstract, cannot. If I did not put it abstract, it means that this method is an abstract method by default. Okay, by default, so means that you need to end with a semicolon. You cannot say this way anymore. This is invalid in the interface file. Everything must be abstract. Okay, everything must be abstract. So you can just ignore the abstract keyword. By default, it will make it as an abstract. Follow on? By default. And let's say I declare one thing int A. Can I do that? This is not allowed. Like compiler, you already see the compiler is start to complain int A, or maybe int x over here. A quite confusing. So this int x, you can see the compiler say is an error. Why is the error? What missing? Constant, right? If a constant, you need to assign the value. It's a constant, you need to assign the data. You see? Okay, you cannot say that you create a variable. So this one is a constant, is no longer a variable anymore. So means that by default, if you put in integer x here, the compiler will try to add the final keywords for you. Even though you did not write this final, it will automatically add it for you. Okay, this final. Okay. Then again, the public keywords in here is also become optional. Okay, everything inside the interface, it must be public and abstract. Okay, everything inside the interface must be public and abstract. So even though I did not put this one, it's still considered as a public access modifier. Okay, same thing from here. You cannot put a private. Okay, there's no way for you to put the private anymore. Everything inside interface must be public. Okay, so even though you did not put this access modifier, by default the compiler will add in this for you called public. Okay, right? Okay, so this one you have to know. So difference between abstract class and interface class, what are the differences there? Abstract class, you can have data. You can have data attributes. Okay. Interface class, you can only have constant. Okay, of course, in the abstract class, if you want to add a constant, yes, you can add it in. You get it? You can add the constant, you can add the common attributes over here, but in the interface, you can only have final. Okay. Then all the method inside the interface only abstract. You cannot have a complete method inside here. Okay, so this is mentioned in the notes that interface file can only contain the constant, can only contain the abstract method. Whereas for the abstract class, you can have all these things. One more thing in here. Can I have a constructor? Interface have constructors or not? Can I just add in the one constructor here, public? This method called A. Can do so. Okay, can see from here, not allowed, right? Okay, interface no constructor anymore. Interface file no constructor, just a constant and the methods only. Okay, right? This one, abstract class, of course, you can have a constructor. Okay, you may try to add one more arrow here. Abstract class can have constructors. Okay. Now, why you need to use the interface? Of course, interface we're going to share the common behavior. Behavior means that the methods, all the methods. In this way, I'm going to say do something. Do something is a method. Okay, so if you have a common attribute, so you're going to put it in as an abstract file. Okay, this is not called a class. This is called abstract file. Okay, this one. Okay, how to add this abstract class in our code? Now, just example in here. Let's say just now we have one file called interval. Okay, this interval we have one method called abstract in here, but of course, if we did not put this abstract keyword, it's still okay. Okay, public abstract, if we did not want to put, we just start from the string. How to it? Yes, it works. Okay, now in here, the difference between, let's see, this one very small. Okay, the difference between abstract class and interface. Abstract class we're using for inheritance. This inheritance we're using as stands. Okay, chicken as stand animals means that the chicken is an animal, right? It's an animal. A stand here means that is a. Okay, relationship is a. But when you say this is a interface file, interface, where is it? Interval. Where is it? Here, interval. This abstract class here. Okay. So in let's say you're using interface file, you need to use this keyword called implement. Okay, a stand and implement difference. Okay, implement means that direct superclass. Okay, interval here means that you're going to share the common attributes, the common behavior. Okay, chickens implement interval means that chicken is a kind of. It's a kind of. Okay, direct parent is called is a relation. Okay, indirect parent is a kind of. So chicken is a kind of interval object. You see? Yeah, you can eat the chicken, right? How to eat? Maybe you fry it. Okay, KFC, you fry it. Okay, same thing from here. The fruit. Same thing. We say the fruit implement interval means that the fruit is a kind of interval object. That it's not is a relation. It's a kind of. Okay, so apple as time fruit means that apple is also a kind of interval object. See that? You get that? In here, why the class fruit you need to make it as an abstract? From here, why the class fruit I make it as an abstract over here? Intervals, you implement the intervals, right? Interval having one method called how to eat, but do you implement how to eat inside this class? You not yet implement, right? Okay, if you not yet implement, means that the fruit class is not yet finished, not yet complete. Okay, not yet complete. So class fruit, you make it as an abstract. So when you come to the apple as time from the fruit, then you need to implement it. How to eat this method. How to eat implement here. Then when you do the inheritance, this method how to eat will inherit to your subclass. Okay, if you did not write this how to eat method in here, that means that the apple class it should be abstract also. Follow on? Okay, this part. Orange as stand fruit means that orange is a kind of eatable fruit. Yeah, right? Okay. What happened in the phase A? So just example, if you want to have this one local student stand from the student view, then if you want to implement, you're using this way, implement. Remember, implement with as implement A. So in this case, when you want to use a stand, you can only extend one file. Okay, local student view extend from the student view. You cannot extend more than one class. But implements, you can implement more than one. Okay, let's say now I have one class A, then I'm going to create one more class, not class, another interface file. Okay, another interface file, maybe I call it as a B lah. Okay, this class interface file B. Okay, then this file maybe you try to add some method. Okay, whatever, just a method name. Okay, let's say inside here we have another method name. So you have two interface files over here. One is called A, one is called B. So example, let's say the student. These students sharing the same common attributes. Okay, implement A. Now you want to implement the second, so I can say that common followed by B. Okay, comma followed by C, comma D, E, F, and so on. So implementation, you can implement more than one. So this part we call it as a multiple inheritance. You get that? This one is a single inheritance. Extend only have one extend files allowed. But when you do the implementation, you can implement more than one. Got it? Okay. Now, in case in here, just one more example. Let's say what example you can try to think of using the interface. Interface file, maybe I call it as flying object. Flying object. Okay, now come back to here. I have two interface here. One is called vehicle. Okay, inside the vehicle we have one method called start engine. Okay, all kind of vehicle you should be able to start the engine. Okay, but different way to start. So now I do not know how to implement the start engine. So I put a semicolon over here. Then maybe here I have one more called flying object. Okay, flying object. So there is one method called takeoff. Takeoff maybe aircraft and helicopter, different way to take off. Okay, so now in the car here. Okay, car is a kind of vehicle, right? Okay, it's a kind of vehicle. So what to do? Using extend or using implement? Implement is a kind of implement. Is a vehicle. Is a means that we're using extend. Okay, so it's a kind of we using implement. So implement vehicle. Okay, so once you implement the vehicle, the compiler will start to complain, say that you need to implement this method called start engine. Okay, how to start engine? You just implement a turn your key or push a button, whatever. It implements over here. Then now maybe in the future the car can fly. So we say that this car is a flying object. Okay, so you can have one class, multiple inheritance here, which normally is sharing the same common attribute. So flying object, what is a common attribute? As a flying object, you should be able to take off, you should be able to do the landing. Okay, take off and landing. So as a vehicle, you should be able to start engine, stop engine, okay, speed up, slow down, etc. Okay, different object, different way to start engine, speed up, slow down. So in here, you can have more than one inheritance. So this car, again, after you put in this, what missing? The compiler will try to complain that this takeoff function is missing. Okay, so you try to implement it. So in the case here, Alright? Okay, so now after using the implement, how to draw the UML class diagram. So different ways to draw again. Okay, last time when we said car using this arrow, okay, vehicle. So car stand, right? This is an stand. But now I'm using implement, so implement you using this way. Okay, dotted line. Flying object. Okay, so take notes. Stand you using a solid line. Okay, solid line. Then when you come to the implement, then you have to using the dotted line. Okay, so car, implement, vehicle, car, flying object means a car is a kind of vehicle. It's also a kind of flying object. Okay, this part? Get this? So in here, clear in the notes, they're giving you another different things. Tiger as an animal. Okay, tiger is an animal. But what happens if I try to implement in the book? Can you eat tiger? Maybe. Okay, but tiger is an animal. Tiger is an animal, so we do the standard. If you want to eat the tiger, then implement in the book. Okay. Okay, clear? So this part I just repeat again. This is what I mentioned just now. In the interface file, under the interface file, public static final and this public abstract is optional. Since the rules say that inside the interface everything must be final, all the method must be abstract. So it's optional. If you did not put, it's okay. Okay, public abstract, public static final. This one you did not put also can. These two code is equivalent. Okay. Okay, comparables. Next one, comparables. Comparable is another interface file. Okay. Okay, comparables. Let's say now I want to do the comparison. Okay, I take the student view again. Okay, student view. Student view, maybe I want to do the comparison which student having the highest view. Okay, maybe the part-time, maybe the local student or international student. What kind of student, which kind of student is having more fees? Okay, others are closing. Okay, so we do implement. Implement what? For the notes, giving you another class called comparables. Okay, this one comparables. Comparable is the class defined in the Java library. Okay, inside the Java library. So you can say implement comparables in here. So comparable, we have one called compare to. Remember what use for this compare to? What is the use for compare to? If you still remember the string last time, the string data type. Yeah, another text of equal. S1 not equals. Okay, S1 not equal S2. Okay, what is the result written? True, right? A and A is the same. You get the answer true written here. But sometimes I want to know which string is greater, which string is lower. Maybe I want to sort the person name according to the alphabetical order, descending order or ascending order. So let's say now this A and B. Which string is bigger? Greater. A greater than B, okay? B greater than A. Okay, this one you know is 65. This one 66. 6, right? Okay, so if you want to know which one is greater, you're using this one called compare to, right? If you still remember, compare to. Okay, get this? String actually extend from the object. String extend from object, implement from comparable. So whatever thing you can do to compare, you can use this one called comparable. So same thing. Let's say I want to compare the student. Okay, maybe I want to compare the fees. Compare the fees. So we come to here, not inside here. Student view, there's nothing for me to compare. Unless I want to compare the credit hour, which student having the greater credit hours. Maybe I want to compare the view. So I should come back to here. A and B I remove. Okay, so I do implement. Here this one comparable. Implements. Okay, implement comparables. Alright, so once you do the implement comparable, now what happened here? The compiler is telling you something is wrong, right? This one? Okay, the compiler is telling you something is wrong because comparable is a interface file. Interface file inside there is a abstract method. Okay, or the interface file there is an abstract method inside. So you haven't implemented the abstract method, then of course the compiler is not happy and complaining here. So what we can do, we try to implement this method called compare to. Alright, if you cannot remember the function method signature, if you remember, of course you can type in. Okay, if you cannot remember, you just click on this one. Click, then you say that implement all the abstract methods. Okay, so you come up this method. Okay, compare to. Alright? Okay, you compare to that. So maybe I want to compare the fees, then of course you can calculate fees and this object passing the fees. Okay? You try to implement how to do the comparison. See this? So inside the notes they're given you, string class is actually extending from the object. Okay? It implement from the comparable. So that's why for the string data type you can use the equals, you can try to use a compare to also. Okay, this is because the parent class is coming from the comparables. Okay, these two classes. Okay, and this one I mentioned already. For dotted line here means interface file. So interface file. Okay, now you need to know that the differences already. Okay, for normal classes, we try to put something the header, right? Then followed by the attributes. Let's say rectangle inside there is height, there is a width, okay, there is a method and so on. This is a simplified UML diagram. Okay, for the classes. Italic means what? Abstract. So this is an abstract class, right? Okay, this is a concrete class. This is an abstract class. Then we have one dotted here means that this is an interface. So interface, normally you can see there's a header called interface. Yeah, all the interfaces, method inside, you need to put the italic because all the method is an abstract. Okay, so all the methods there are abstract. Okay, so this is a UML notation. Okay, you need to know how to draw. Okay, for assignment, I'll leave it to you. I'll leave it to you. In case you want to use the interface, you just use it. Okay, marking rubric do not mention for the interface file. Okay, for the marking rubric. Okay, compared to how to write, almost the same thing like the equals method, we need to do the casting, data type casting. Okay, no other special thing. This is for chapter 7-1. Okay, chapter 7-1. Any question at this part? Any question? No question. Important for the assignment? Yes. Yes, not to say no important. Yes means important. There is one question on the interface. Okay, one question means how many marks you know? You need to know the syntax how to write the interface. Okay, this interface file. Okay, not this one. The name is called interface. Don't make it wrong. The name is called interface, not called as a class. Okay, and don't go and put a bracket. Let's say the function Don't go and put the bracket there. If you put the bracket, then this is wrong. You need to always end with a semicolon. Okay? Got this? Methods, abstract methods should end with a semicolon. Alright? Okay, so we finished so early today. Chapter 2, what is this? It looked like the summary. Is kind of mixed. Okay, maybe this one will continue next week. Okay, for midterm test, you got the results. Some got the results, some still not yet got the result. For your case, you can drop me the email. I try to scan and return back to you. Okay, for your midterm test. Okay, now question from the midterm test. I still see a lot of you doing this way. Okay, public void get name. And you're going to put a return there. What's wrong in this? You know this is a void. How come you can return the value? Not only 1, 2 students, a lot. I thought this one is a common thing for your, let's say your C++ before. This void means that nothing returned. And some more, okay, get method, you go and passing the data. Okay, get method, you pass in the data. Is not name equal to name. Okay, what's wrong with this? Offended. Get method means that you're going to return why you passing the data there. Or maybe you use the insert code too frequent. Insert code, right? Too frequent until you forgot how to write. Okay? Now, try to practice, do more practice. Get method should return the value. And don't go and put a space there. Get student name. Oh, this is a method name. Wow. Method name with a space. I don't know what to say. Okay, name no space. Name cannot have a space. Okay, coding convention, uppercase, lowercase, I will not check so strict. If you put uppercase s or you put lowercase s, I still accept. In the exam, I still accept. But in the coding convention, the s will be uppercase. Okay, we won't check until so strict in your final exam until the uppercase, lowercase. Okay, even though you accidentally put the uppercase p here, in the exam is fine. Okay, right? But get and set method, don't put it wrong. Don't go and do the set method here. Then you're going to do the return data type. Alright? Okay? Okay, other than this one, or others like theory is still okay. Still okay. At least not so horrible. Okay, so any question? Assignment? Can finish on time or not? Week 12. Understand to week 15. Week 15 Monday I have to submit a coursework to the office. Where is the initiating? Week 12 Friday. Week 12 Friday, if you want to understand, week 13. Friday cannot too late for me to mark. Okay, branch told me that branch with name branch told me I start 3 days. That means that Friday supposed to be submission, then I stand to the Monday. Then Saturday, Sunday you still have time to do. Okay, if you want, just follow the same. Okay, they are stand to the Monday, so I just follow stand to the Monday. Okay,
Okay.
Alright. Okay, no question today. I will add a slightly any question you can come forward. Remember to take attendance. Okay, remember to take attendance.